Welcome to this video in which we are going to explain how Juno Cassandra fits into the wider Juno ecosystem. Now I just want to emphasize that this video is made in October 2024, and as such some of the diagrams and information given in this video may change over time. So please be just sure to see if there's an update to this video if you are watching this video sometime in 2025 or later. Now just some background about JunoAMS and Cassandra. JunoAMS means the Juno Asset Management System. Generally, this system has been known over the years as Juno Viewer, or many clients refer to as simply as Juno. Now, JunoAMS is the name that we are using for the wide ecosystem in which we are striving now to make our different modules and features of JunoAMS more modular, so that you can actually purchase different items separately as part of the Juno Viewer framework. Juno Cassandra falls then within the modeling module known as JunoModel. Cassandra can be licensed as part of the JunoAMS or as a separate component. So if you are a deterioration modeler or an analyst looking simply for a world-class infrastructure deterioration model that can handle machine learning and other complex types of functions, then Cassandra can be very useful for you as a standalone tool, and you do not need the wider JunoAMS ecosystem in order to use it. At the same time, if you are already a user of JunoAMS and you already have a license for it, then Cassandra fits in very nicely with that license that you already have. So let me just explain a little bit about the JunoAMS system and the different components that make it up. The basis of JunoAMS is what we call Juno Viewer. This is essentially our cloud-based data management system. It's the foundation for JunoAMS, and this ensures that your data is stored very securely in a centralized location. The Juno Viewer Foundation ensures that you have comprehensive data management, and it creates the shared tools for analysis and reporting that are used by the other components. Juno Viewer is completely cloud-based. In other words, you can access it through your browser, and also you can interface with Juno Viewer through application programming interfaces or APIs that can talk to your other organization systems. The first module then in the JunoAMS, apart from the Juno Viewer backbone, is JunoPlan. JunoPlan is used for future works program development or management, or forward program management, and this is one of the most often used features of the JunoAMS system. It allows you to centrally plan, validate and manage your work programs, and you can do certain of the elements in JunoPlan either in the cloud, or you can do it off-site where you don't have an internet connection. I'll talk more about that in the next slide. So there's a lot of features in JunoPlan that allows you to manage your forward programs with built-in strip maps, tables and reports. Then there is JunoModel. This module is basically our Infrastructure Deterioration Modelling framework. It facilitates multi-objective, multi-constraint model execution and optimization, and it can handle in Juno Cassandra models for different asset types. So things like water networks or road networks or bridge networks, etc. And this model can inform both the strategic planning and short-term operational planning for works programs. Then there is our Juno Intelligence module, which is our AI-assisted fault and asset detection module. This module allows you to capture videos either with a GoPro or with a Juno app, and we will use then our sophisticated AI models to detect faults and assets from the video, analyze the results and assign that data back into your Juno Viewer database as shown by this arrow here, and from there you can create custom reports. You can also modify and tweak the labels that have been assigned by the Juno AI system. Then there is Juno Bridge, which is our bridge information and management. This allows you to carry out inventory collection and bridge analysis in the field, and as features specifically for reporting on bridges. And of course, this will interface also with JunoModel for running models to optimize the placement of treatment in bridge management systems. Then there is JunoJob, which is our routine maintenance management system, and this system allows you to design custom inspection forms for routine maintenance and manage basically the workflow for routine maintenance, such as inspection, incident management, etc. And this is a highly customizable system to customize inspection forms, etc. for your needs. As indicated by these arrows, the Juno job system can interface in different ways with the other modules that are available. And you can essentially purchase some of these modules separately. Generally, almost all our clients currently use JunoAMS as a complete system. And of course, one other thing to mention here is that Juno Intelligence specifically is highly useful to link to JunoModel, because the distresses that are detected with Juno Intelligence are very, very relevant for the modeling procedures to identify the elements in a model that are most urgently in need of treatment. But this linkage is not formalized. You can take the information generated with Juno Intelligence and use that as inputs in your model, but that requires custom decisions and so forth that I won't cover in this video. So let's just take a different look at the JunoAMS system and how all of these pieces fit together. So here we have the Juno Asset Management System, or JunoAMS, as I've already explained. And there are two main families of tools in JunoAMS. The first is the online tools, which are basically the browser access through the browser, and then also the application programming interfaces, which is basically the APIs that your system can talk to push data to and fro from JunoAMS to your systems that can use the information and the reports generated by JunoViewer. And then there is the offline, desktop, and the mobile apps family as well. So as I discussed earlier, JunoViewer component forms the backbone for data analysis and management and for security. Then there is JunoPlan, which is the the forward works program management component. And this component has an offline tool, which is what we call our offline field inspection tool, or FIT, F-I-T. And this allows you to take your forward works plans into the field, go and validate and inspect them, make comments, etc., and move treatments around as needed, and then sync that information back into the cloud so that your team can, in a central way, approve the modifications and also view it. Then there is JunoModel. Now I've made this a little bit of bigger box because this video after all deals with the modeling component Cassandra. So JunoModel interacts quite closely with the forward works program management, of course, and built into the cloud-based system we have what is known as our DMS based model. Now DMS stands for Deterioration Model Setup File, and this is basically a file in which the calculation engine that defines your model is held in an Excel spreadsheet. And the DMS model then loops over all of your data, puts it in the calculation engine, calculates the optimal treatments, and pushes that out again into your forward works program. Now Cassandra is a offline desktop component that is a completely new framework for deterioration modeling. However, if you want to push your data from Cassandra back into JunoViewer, you will still be pushing the model outputs into a DMS template so that we can interact between JunoModel and your forward works program management. And I'll explain that in a bit more detail shortly. Then there are the other components like JunoJob, which has the Juno app for inspections. Then there's JunoBridge, which also has the Juno app for inspections, taking photos on site, syncing it back for reports, etc. And Juno Intelligence, which has also Juno app to capture videos. And there are also some desktop tools that allow you to sync videos up to our server from where inferencing can then take place, so that the identified distresses and assets can be logged in your database. So if we look at Cassandra and JunoAMS and specifically the interfacing between these two components, here I have the JunoAMS, which is a cloud-based system. You access this through the browser, and generally you will get your model elements maybe from an outside system. You can also use some of the tools we have in JunoViewer to do uniform subsectioning and generate the model segments inside JunoViewer. If you are using an outside system to get your model elements definition, so the starts and ends, etc., you can upload that into JunoViewer. That will create your base ForwardWorks program. And you can then use the data that you have in your asset management system in JunoAMS to basically join information that is needed by your model and your ForwardWorks program inspection teams. And you can join that data into your ForwardWorks program with JunoViewer's data join tools and features. Then we have Cassandra Desktop. So once you've got your ForwardWorks program prepared with all of the data joined in, you can download that information to the desktop, and Cassandra has tools to parse that ForwardWorks program and help you to rename columns so that you can prepare it for your Cassandra model. Now, the reason you may want to rename columns is just that in JunoViewer, generally columns that are generated with data joins are prefixed with the prefix info underscore, and in a Cassandra model you most likely will have a more formal naming system for your input set. So typically we may prefix all the columns in an input file with IN or INP or file underscore, etc. So there are tools in Cassandra to help you. If you've got 50 columns or 100 columns in your input file, you don't want to manually be renaming them every time that you download a ForwardWorks program from JunoViewer. So if you set up a template for the renaming once, Cassandra can take care of that and rename it to create your draft input set. Once you have your input set then prepared, you will do your model analysis, run the models, finalize the ForwardWorks program that you want to propose for field inspection. And there is then also a tool in Cassandra to prepare for you a zip file which contains your model outputs, all of the predictions made by the model, as well as all of the treatments. And it will also create for you a dummy DMS that will allow your Cassandra model to link to your Juno model. You then upload that file, and there is a tool that our team is currently refining to take that Cassandra upload and automatically update the master ForwardWorks program that you originally downloaded the data from. And so once you've done that, you can now go and take that Cassandra that is in JunoViewer. You can take that ForwardWorks program and you can use our suite of inspection tools like the virtual field inspection tool, which you can access from the cloud to look at available videos. You can see here you've got your ForwardWorks plan with the treatments in different years, and you have many different ways of looking at your data and making decisions about your ForwardWorks program. Video specifically is very, very useful in this validation process, at least for what you are doing from the comfort and safety of your office. Then there's also the centralized forecast view that allows your team to all look at the same ForwardWorks program. You don't have to send spreadsheets around and so forth. And you can see where you have gaps in your program, things that need to be addressed, etc. And this is what is known as the forecast view in JunoViewer. So that is it for this video. I just want to close off by saying that as our Cassandra client base grows, Lonrix will work quite urgently to make this interfacing between JunoAMS and Cassandra as seamless as possible. Currently, there still needs to be some manual downloading and uploading of files. I think in the near future, we will be able to achieve that through automatic interfacing between Cassandra Desktop and JunoAMS. We also plan to release a cloud-based version of Cassandra in the future, but we are just going to build up a good user base first and refine the tool quite significantly before we attempt the cloud-based development, which is generally much more intensive and expensive to do. So if we have a good desktop version working with that many clients are satisfied with, we will use that as the model for how the cloud-based version should look. Whether you are working in the cloud or the desktop, Cassandra will be available to purchase as a standalone tool. So just again to reiterate, if you are a modeling analyst working on your own and you are looking for a good standalone infrastructure deterioration modeling tool, Cassandra may be the tool that you are looking for. So that's it for this video. Thanks for watching.